Right, this is completing the square like you were doing before, but this is just an alternative way of doing it. And I need to show you this because this is most likely the method that you will use in higher. And when you get to higher, you have to write quadratic functions that are slightly more difficult in completed square form. So you'll notice with all of these ones, they have a singular x squared. So basically have a 1 in front of the x squared. When you get to higher, that changes, and then everything thereafter changes. And it's a little bit more difficult. At this stage, it's not so bad. But the method that most of us use to do this is equating coefficients. What that basically means is matching up kind of the value of the x squareds and the values of the x's and the values of the constants with the multiplied out version of the general form for completed the square. So this is generally what you'd see, and the letters will change. I've used Q and R here, and you might never actually see Q and R. A lot of people use P and Q, M and N, A and B, okay? But the letters will always change. Now, whatever they change to, you can still use this method, but the point is we want to multiply this out first so it looks more like these three questions, okay? So because we've got the same form, we're going to use the same form, we're going to multiply out the same form only once. So that's what we're starting with, x plus q all squared plus r, right? One thing you need to remember when you've got something like x plus q all squared like this is it's not x squared plus q squared. This is where you have to think about FOIL, and you have to write it as two brackets like so, and then multiply it out properly. So x times by x, the first terms times together, plus x times by q, and so on and so forth. Right, you can simplify that a little bit, because when you do x times by q and then q times by x, you basically get two qx's. And then obviously the q times by the q will give you the q squared. So you might want to write an extra stage in there, but when you simplify it down, it'll look like this, and don't forget the plus r at the end. Right, this looks quite confusing. X squared plus 2qx plus q squared plus r. But the point is now, I have an x squared and I have an x term, and I can see the coefficient of each of them. And what I basically want to do is I want to now match them up to the coefficients I have in the questions. Okay, so I'm going to take this x squared plus 2qx plus q squared plus r, and I'm going to match it up with the first question, x squared plus 6x plus 2. And what I'm trying to do, as I say, is match up the x squareds with the x squareds, the x's with the x's, and then basically everything that's left with everything that's left, okay? And this might look a little bit confusing, but when you get into the practice of this, okay, it becomes quite straightforward, okay? Right, so for this one, the x squareds basically match up anyway. So we don't need to worry about them. X squared is equal to x squared, that's fine. As I say, when you get to higher, when you do this a little bit more difficult questions, versions of this, then they're not going to match up. But they pretty much take care of themselves. So then we move on to the next part. We're matching up the x's. So we can say that 2qx needs to, and that's basically what we're doing here, equals 6x. If these two things can be written in the same way, then 2qx is going to need to equal 6x. And from that, I can basically work out what my q must equal, okay? 2qx equals 6x, so 2q must equal 6, in which case q must equal 3, okay? Now that's the value that I'm going to put in to the version I had at the start, okay? So I know my q number now, okay? Now I just need to find out what r is. And using that second kind of bubble, I've got q squared plus r needs to equal 2. So for this to happen, q squared plus r needs to equal 2. Basically everything else that doesn't have an x in it needs to equal each other. So the q squared plus r needs to equal 2. Right, I wouldn't be able to find this one first. This is why I had to do the kind of the blue bubble first. But because I now know what q is, I know what q squared is. Okay, it's going to be 3 squared plus r is equal to 2. In which case r is going to equal minus 7. What we've basically got there is 9 plus r equals 2, and then just solve it like an equation. Take away 9 from both sides, r will equal 2 minus 9 is minus 7. And as long as I know what my q and my r are equal to, I can write my final answer. This is just x plus 3 all squared minus 7. Okay. Right, there are shortcuts even beyond this. And a lot of you might start to be able to see that just now. And especially once you get through these three questions, certainly to get the Q, you'll start spotting a shortcut. The R is a little bit more difficult, okay? I'm going to leave that with you just now. I'm not going to tell you the shortcut until further down the line. But if you can spot it, then that's absolutely fine. But you will need to be able to do this method to move into higher, okay? Right, so the second one, we've got x squared plus 8x plus 3, but we're still going to match up with the coefficients from the expanded version of x plus q all squared plus r, okay? So my x squared and x squared, they match up. I want my 2qx and my 8x to match up, and then the q squared plus r plus 3 is going to need to match up too. So I just basically form my equations based on that. 2qx is going to equal 8x, in which case 2q must equal 8, in which case q must equal 4. So now, again, I know the number that goes in my brackets, but I need to find out what goes outside the brackets, and I use this green bubble to do that. So I know that q squared plus r is going to have to equal 3 this time. I now know what my q is, so I know that 4 squared plus r is going to have to equal 3. 4 squared is 16. 16 plus whatever r is equal to 3. And again, just solve it like an equation. Take 16 off of both sides. R is going to equal 3 minus 16, which is minus 13. Okay, so x plus 4 all squared minus 13 is x squared plus 8x plus 3 written in completed square form. Okay, so the final version there, again, we're still equating with the same coefficients, so I'm still matching up with x squared plus 2qx plus q squared plus r, but I've got x squared minus 12x minus 13 now. So just careful with your negatives here, but still doing the same thing. And the x squareds will match up. As I say, in National 5, they should always match up, so you don't necessarily need to worry about that. It's just everything that comes thereafter. So 2qx equals 12x, 2q equals 12, q equals 6. I've got my number in my brackets. So then everything else, the q squared plus r must equal everything else, 13, minus 13. And be careful, it has to equal minus 13 here. So if you made it 13, then it's going to give you a different answer to what's required. We know what q is now. Q is 6, so then 6 squared is going to equal 36, in which case r is going to equal minus 13. Take away that 36, which is minus 49. Mistake, sorry guys. Okay, x squared plus 6 squared minus 49, okay, is our answer there. And obviously once we get this, we can work out the turning point, we can work out our axis of symmetry. There's lots of different things we can do. But that's the point of the completed square form. It allows us to kind of read different things in terms of the graph. But this method, this way of doing it, there's nothing wrong with the way that you've looked at before. And as I say, there's other ways of doing it. There's perhaps shorter versions of doing it. But this is the way that it will be most commonly used going forward.